The F-60 Spector is a name that sparks curiosity, mystery, and excitement among aviation enthusiasts. Imagine a fighter jet designed not just for today's battles, but for the conflicts and challenges of the future. Built around the concept of absolute air dominance, unmatched stealth, and revolutionary technology, the F-60 Spector represents what many believe could be the next giant leap in military aviation. While the aircraft remains a conceptual vision rather than an officially deployed fighter, the idea behind it combines some of the most advanced technologies currently being developed around the world. The result is a machine that appears to belong more to science fiction than reality. For decades, fighter aircraft have evolved through generations. Each new generation introduced capabilities that completely changed the nature of aerial warfare. The transition from propeller-driven fighters to jets transformed speed and maneuverability. Later generations introduced radar-guided weapons, fly-by-wire systems, stealth technology, and advanced sensor fusion. The F-60 Spector is imagined as a fighter that takes all these developments and pushes them to a level never seen before. At first glance, the aircraft's design immediately stands out. Every surface is shaped to minimize radar reflections. Sharp angles, smooth contours, and carefully engineered air intakes work together to reduce its radar cross-section. Unlike older stealth aircraft that focused primarily on avoiding radar detection, the F-60 Spector is designed to minimize signatures across multiple detection methods. Infrared emissions, acoustic noise, electronic signals, and even visual visibility are all reduced through advanced engineering techniques. The aircraft's airframe is constructed using next-generation composite materials. These materials are lighter than traditional metals while offering superior strength and durability. Advanced radar-absorbing coatings cover the entire surface, allowing the aircraft to blend into the electromagnetic environment. Engineers envision materials that can even adapt their properties during flight, providing dynamic stealth capabilities depending on mission requirements. Powering the F-60 Spector are two highly advanced adaptive cycle engines. Unlike conventional jet engines, adaptive cycle technology allows the engine to change its operating characteristics during flight. When maximum speed is required, the engine can deliver tremendous thrust. During long-range missions, it can switch to a fuel-efficient mode, extending operational range significantly. This flexibility provides both performance and endurance, two qualities that are often difficult to achieve simultaneously. Speed remains a critical factor in air combat, and the F-60 Spector is designed with this in mind. Estimates suggest it could achieve speeds well beyond Mach 2 while maintaining excellent fuel efficiency. More importantly, the aircraft would possess supercruise capability, allowing sustained supersonic flight without using fuel-hungry afterburners. This enables rapid deployment across large distances while reducing infrared signatures. The cockpit represents another dramatic departure from traditional fighter designs. Instead of relying on multiple screens and physical controls, the pilot interacts with a fully integrated digital environment. Artificial intelligence acts as a constant assistant, processing enormous amounts of information and presenting only the most relevant data. This reduces pilot workload and allows faster decision-making during combat situations. Advanced helmet-mounted displays project information directly onto the pilot's visor. Enemy aircraft, friendly forces, navigation data, weapon status, and mission updates are all visible without requiring the pilot to look away from the outside environment. Some concepts even suggest the possibility of augmented reality systems that provide a complete 360-degree view around the aircraft using external cameras and sensors. One of the most revolutionary aspects of the F-60 Spector is its artificial intelligence integration. Modern fighter jets already use sophisticated computers, but the Spector concept goes much further. The onboard AI continuously analyzes threats, predicts enemy behavior, recommends tactics, and assists with target prioritization. Rather than replacing the pilot, the AI serves as an intelligent partner capable of processing information at speeds no human could match. Sensor technology is equally impressive. The aircraft combines data from radar systems, infrared sensors, electronic warfare equipment, satellites, and allied platforms into a single integrated picture. This sensor fusion capability gives the pilot unprecedented situational awareness. Instead of viewing separate streams of information, all data is combined into a clear and understandable format. The radar system itself is expected to be among the most powerful ever installed in a fighter aircraft. Utilizing advanced active electronically scanned array technology, it can track multiple targets simultaneously at extraordinary distances. Unlike older radar systems, it can rapidly switch frequencies, making it difficult for enemies to detect or jam its signals. Electronic warfare capabilities play a central role in the aircraft's design philosophy. Future conflicts are expected to involve intense electronic battles where information dominance becomes as important as physical firepower. The F-60 Spector can disrupt enemy communications, confuse radar systems, interfere with missile guidance, and protect friendly forces through advanced electronic attack techniques. Weapons systems aboard the aircraft are equally advanced. Internal weapon bays preserve stealth characteristics while carrying a diverse selection of air-to-air and air-to-ground munitions. Long-range air superiority missiles allow engagement of enemy aircraft before they can respond. Precision-guided bombs provide exceptional strike capability against ground targets. Future concepts even envision directed energy weapons becoming part of the aircraft's arsenal. High-energy lasers could potentially intercept incoming missiles, disable enemy sensors, or engage aerial targets at the speed of light. While significant technical challenges remain, such systems are becoming increasingly realistic as power generation and energy storage technologies improve. The aircraft is also designed to operate alongside unmanned systems. Instead of fighting alone, the F-60 Spector serves as the command center for a network of autonomous drones. These drones can scout ahead, carry additional weapons, conduct electronic warfare missions, or act as decoys. The pilot controls the overall mission while artificial intelligence coordinates the actions of multiple unmanned teammates. This concept of manned-unmanned teaming represents one of the most important developments in modern military aviation. By extending the aircraft's reach through autonomous systems, commanders gain greater flexibility while reducing risks to human pilots. A single F-60 Spector could effectively command an entire airborne task force. Survivability remains a key requirement. Beyond stealth and electronic warfare, the aircraft incorporates advanced defensive systems. Missile warning sensors provide immediate threat detection. Automated countermeasure dispensers deploy flares and decoys when necessary. Future defensive technologies may even include directed energy systems capable of destroying incoming threats before they reach the aircraft. Range and endurance are also significantly improved compared to earlier fighters. Advanced fuel efficiency, optimized aerodynamics, and intelligent mission planning allow the aircraft to operate over vast distances. This capability is particularly important in regions where military operations may involve enormous geographic areas. Maintenance requirements are another area where significant improvements are expected. Traditional stealth aircraft often require extensive maintenance to preserve their low observable characteristics. The F-60 Spector is designed with maintainability in mind. Modular components, self-diagnostic systems, and durable stealth materials reduce downtime and increase operational readiness. The aircraft's communication systems reflect the demands of modern warfare. Secure data links connect it to satellites, ground forces, naval assets, and other aircraft. Information flows instantly across the battlespace, creating a highly connected combat environment. Real-time intelligence sharing allows rapid adaptation to changing battlefield conditions. In air-to-air combat, the F-60 Spector possesses extraordinary advantages. Its stealth characteristics allow it to detect opponents long before being detected itself. Advanced sensors identify threats at extended ranges. Long-range missiles enable engagements beyond visual range. If a close-range dogfight becomes necessary, powerful engines and advanced flight controls provide exceptional maneuverability. Against ground targets, the aircraft demonstrates equal effectiveness. Precision weapons can strike critical infrastructure, command centers, air defenses, and other strategic objectives with remarkable accuracy. The combination of stealth and advanced targeting systems allows deep penetration into heavily defended airspace. Maritime operations are another important mission area. The aircraft can conduct reconnaissance, anti-ship strikes, and fleet defense missions. Long-range sensors help locate naval targets while precision-guided weapons provide effective engagement capabilities against surface vessels. The strategic impact of such an aircraft would be profound. Air superiority has long been a cornerstone of military power. Nations that control the skies gain significant advantages across all domains of warfare. The F-60 Spector's advanced capabilities would strengthen that advantage by combining stealth, speed, intelligence, and connectivity into a single platform. Training pilots for such an aircraft presents unique challenges. Future aviators must understand not only traditional flying skills but also advanced computer systems, artificial intelligence integration, electronic warfare, and network-centric operations. Simulation technology plays an increasingly important role in preparing pilots for these complex environments. The development costs associated with such an advanced aircraft would likely be enormous. Cutting-edge technologies require extensive research, testing, and validation. Balancing capability with affordability becomes one of the central challenges facing defense planners. Nevertheless, history shows that technological superiority often provides strategic advantages that justify significant investment. Global military competition continues to drive innovation. Nations around the world are pursuing next-generation fighter programs that emphasize stealth, artificial intelligence, advanced sensors, and autonomous systems. The F-60 Spector concept reflects many of these emerging trends and illustrates how future combat aircraft may evolve. Environmental considerations are becoming increasingly relevant as well. Engineers are exploring methods to improve fuel efficiency, reduce emissions, and develop more sustainable aviation technologies. While military effectiveness remains the primary objective, environmental factors are likely to influence future aircraft design decisions. As technology continues to advance, the boundaries between science fiction and reality become increasingly blurred. Features once considered impossible are now entering active development. Artificial intelligence, autonomous systems, directed energy weapons, advanced materials, and adaptive engines are no longer theoretical concepts but rapidly progressing technologies. The F-60 Spector embodies the vision of what future air combat may look like. It combines the lessons learned from decades of aviation development with emerging technologies that promise to redefine military capability. Every aspect of the aircraft is optimized for information dominance, survivability, flexibility, and effectiveness. Whether such an aircraft eventually appears under the name F-60 Spector or another designation, the ideas behind it are shaping the future of aerospace engineering. Military planners, engineers, and strategists continue working toward systems that can operate effectively in increasingly complex and contested environments. The sky has always been a domain of innovation and competition. From the earliest biplanes to